Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today secant and tangent angles. This will be involving the circle and a combination of two tangents or a tangent and a secant. Okay. All right. So we're after the angles here. We're solving for angles or sometimes the arc. Okay. All right. So let us see the problem set first. Okay, let us check the problem set and okay, let's start with from the beginning. Yes, let's start from the beginning. All right, so this will be about 36 problems, okay? And this will be secant and tangent angles. And the instruction is find the measure of the arc or angle as indicated, okay? And we shall solve each type of combinations. So, all right, there are several combinations here. All right, so we have here tangent and a tangent, tangent and a chord, okay, and that is extended. So, chord with an extension is a secant, and we're asked to find x. We're asked to find angles and arcs there. And this portion numbers 15 and 16 involving a tangent and a secant. Okay, so there. And we're still after angles or arcs. Okay, so we shall try to solve each type of combination. Okay, combinations there. There are several combinations. Here we have uh, two intersecting chords. Okay, two intersecting chords there inside the circle. Okay, of which we can also consider as two intersecting secants. Okay, all right. So the title is secant and tangent angles. All right. So we're after several types of problems here. All right. This is a long worksheet, and we shall try to solve it one by one. All right. So let's start with the first number. Okay, we shall have the presentation view, the first number. Okay, over here. Let me clear the answer first. All right. So find the measure of the arc or angle indicated. Assume the lines which appear tangent are tangent. All right. If you click here right away, it shows the answer. Okay. So if you click here, but let us see the solution. All right. Find the measure of the arc or angle indicated. We have here two tangents intersecting at the exterior, forming the angle 46 degrees. Okay. We're after the arc, which is marked with a question mark over here. You can see this arc here. All right, that's the bigger arc, and we have the smaller arc over there. Okay, and none of them is given. Okay, uh, none of them is given, and so we shall try to put expressions there which will allow us to solve it. All right, so if we can put here a question mark, that means it's the unknown measure, unknown arc there. Okay, unknown arc. Now, if that will be x, then the other arc will be 360 minus x. One full circle minus the x there. And so the theorem here is the the intersection of two tangents form angle. Okay, we have a theorem here. Okay, if two tangents intersect at the exterior of a circle, okay, of a circle, then the angle, the measure of the angle form, the angle form is 1/2. Okay, is 1/2 the difference of the intercepted arcs. there. Okay, and we shall put this in the clipboard. Each time we encounter this, we can write the theorem. Okay, if two tangents intersect at the exterior of a circle, then the angle formed is 1/2 the difference of the intercepted arcs. Okay, all right, so we can put the x there in the major arc, and then the minor arc is 360 minus x. All right, and so our working equation will be the bigger arc x. This will be for the equation. Okay, we have x minus, all right, the smaller arc will be 360 minus the x there. And then we divide this by 2. Okay, and so this is equal to 36. This must be equal to the angle formed outside. Okay, all right, so this will have a divide, of course. This will be x minus the 360 minus x, the smaller, divided by 2, which is equal to 46. So the angle formed by the tangents is 1/2 the difference of the intercepted arcs. Okay, all right, solve for x first. So we start here with, we have here x minus 360. All right, that will be minus, and a minus x, that's a plus x now. There. And we have to divide this by 2. And this will now be equal to 46. Yes. And this will now be, of course, divide. Okay, x and x is 2x. So we continue with 2x minus 360. And we divide this by 2. And this will still be equal to 46. There. Then we put the divide. Okay, so 2x is divisible by 2. 360 is divisible by 2. So the equation simplifies to x minus 180, which is equal to 46. We proceed by addition property, add 180, add 180, all right, to both sides of the equation, and x is found. X is equal to, how much is that? 6, 12, that looks like 226. 226, yes. 226 degrees. There. All right, so that will be the answer. All right, let's check and verify. You can check the answer below the diagram. There, it's 226 degrees. You can see it over here, which is exactly what we have here. That should be the answer. All right, let's continue with the next, number 2. Let me clear the screen and the answers. Proceed to number 2. All right, here's another of the same diagram. We have two tangents intersecting outside the circle. We're asked to get the angle outside the circle. All right, so we shall use the 245 to solve for the smaller arc first. Okay, the smaller arc here in the diagram, you can see it here. It will now be 1 full circle minus the 245 there. Okay, that will be the smaller angle, and that will be how much? That's 360. Yes, that's 360 minus the 245 there. Okay, so this is 5, and this will be 1, and that's 115. Okay, all right, so the smaller arc there is 115. Okay, and so we can replace that with 115. Okay, let's change this. All right, this is now 115. So this is 115 there. All right, so the bigger arc, here's our working equation. We're looking for the angle LMN. Okay, we're looking for the angle LMN. So this will now be a measure of the angle LMN. We put the symbol angle there. All right, and this is equal to the formula. The bigger arc 245 minus the smaller arc 115 divided by 2. Okay, we shall divide this by 2. And that's it. Okay, there. And so this is equal to okay, this is equal to 245 minus 115. So that'll be 130. Yes, that'll be 130. 5 and a 5, 4 and a 1, and 2 and 1. So 130 divided by 2. So we shall divide this by 2. And so the answer is just 65. So this is equal to 65 degrees. That should be our answer. Okay. All right. So that should be our required answer. All right. That's the angle over there. That should be 65 degrees. Okay. Check and verify. Yes. Okay. You can see the answer below the diagram over there. So this must be correct. Let's do number 3. Let me clear the screen and the answer and proceed to the third. All right, here's the third number. Solve for x. Okay, solve for x. All right, so in this problem, we will still use the same. Okay, this particular theorem. If two tangents intersect at the exterior of the circle, then the angle formed. Okay, there is 1/2 the difference of the intercepted arcs. So it will still be the bigger arc minus the smaller arc divided by 2. And that'll be equal to the angle there. All right, so let us write our working equation. This will be the bigger arc, 41x minus 2. That's the bigger arc. Minus the smaller, that's 19x plus 2. And then this will be divided by 2. 1/2 of the difference must be equal to the angle, which is 8x plus 16. So this is 8x plus 16 there. Okay, we shall just put the divide at the left side. This will be a divide like that. All right, solve for x here. Okay, solve for x. So let us see how we can simplify it first. All right, removing the parentheses, it will be 41x minus 2. We have a minus 19x, and that becomes a minus 2 there. And this will still be divided by 2. Okay, and this will still be equal. All right, this will still be equal to 8x plus 16. Yes, there. All right, the divide symbol will still be over there. This will still be divide there. All right, how about 41 minus 19? 11 and 9 is 2, 3 minus 1 is 2. 22x, yes. So this is 22x, and we have a minus 4. That becomes 4, yes, minus 4, and then divided by 2, still equal to 8x plus 16. There, all right. We still have the divide. Okay, so 22 divided by 2 is 11x, and 4 over 2 is 2. That will be a minus 2 there. This will still be 8x plus 16. Okay, so we subtract the 8x. We shall have a minus 8x and a minus 8x. And we shall get the next line. This will be 3x minus 2. And this will be equal to 16. And then we proceed by addition of 2. We add 2 and we add 2. All right, so the next part of the equation will now be just 3x. We can do it over here. This will now be like 3x equals 18. Okay, this will be 3x equals 18. All right, and so after dividing by 3, we divide this by 3 and divide this by 3. X looks like 6. Okay, so this will be x is equal to 18 divided by 3 is 6. Yes. All right, so this is divide. We shall put the divide there. Okay, final answer is 6. All right, over there. Let's check and verify. Is it 6? Yes. All right. You can see it here. And so that explains our solution for number 3. Let's do number 4. All right. Clear the screen and proceed to number 4. All right. Here's number 4. Okay. The same configuration, 2 tangents intersecting outside the circle. And we will still follow the same concept. This arc minus this arc divided by 2 must be equal to this angle. All right. Okay, so first we shall get the bigger arc. Okay. All right, the bigger arc will be, how much is that? 360 minus the smaller 121. So this will be a 9. This is 5 minus 2, that's 3. It's 239. Okay, so we have the bigger arc here. This is 239. Okay, 239 degrees. All right, so we can now form our equation. All right, it's 239 minus 121. Okay, that's minus 121, the smaller. Divide this by 2. And this will now be equal to 59x, the angle. Okay, and we're just after the x here, so we can solve for x here. So it's 239 minus 121. Okay, so this will be 8, and this is 1, and that looks like 118. So we have here, our next line is 239, okay, minus 121. Okay, that's 118. And we still have to divide this by 2. There. We have just completed the subtraction, so we haven't divided it by 2 yet. So this is equal to 59x. There. And so this will still be divide. All right, 118 divided by 2, that's 50 and 9. So we have a 59. So this is 59 is equal to 59x. And that can be written 59x equals 59 by symmetric property. And then we shall divide by the 59. And so final answer is 1. Okay. All right. After division, this is equal to 1. And x is just equal to 1. All right. That will be our value for x. We can check and verify the answer near the diagram. Is it 1? Yes. All right. There. So this must be correct. Number 5. Let's do number 5. Let me clear the screen. Here is number 5 diagram. All right. We still have 2 tangents intersecting outside the circle. Therefore, we can still apply the theorem. If 2 tangents intersect at the exterior of a circle, then the angle formed is 1/2 the difference of the intercepted arc. Let me retype this. Okay, let me retype this. I can see a missing letter R. Theorem: if 2 tangents intersect at the exterior of a circle, then the angle formed there should be an R there. The angle formed is 1/2 the difference of the intercepted arcs. There. Okay, then we put this at the clipboard. All right. Okay, so this is it, and then let me clear the first one. It's already at the clipboard, so we can put this. All right, let me retype it here. There. there. Okay. If two tangents intersect at the exterior of a circle, then the angle formed is one half the difference of the intercepted arcs. All right. And so we can still follow the same principle using this number 5 diagram. All right. So we have the bigger arc minus the smaller arc divided by 2. All right. One half the difference. All right. That will be the angle formed. Okay. And so we shall have the bigger arc marked 360. So this will be 360 minus 111x. Okay, there. That will be the expression for the bigger arc. One full circle minus the given arc will be the bigger arc. And so our working equation here will now be all right, finding the measure of the angle FED. So we're asked to get the angle FED. Okay, and so this will be 70x minus 1. So we shall solve this separately over here. Okay, so the measure of angle FED, and this will be marked angle. This will be marked angle. All right, there. The measure of the angle FED is equivalent to 70x minus 1. Okay, so this is equivalent to 70x minus 1 there. Okay, that'll be our formula for the angle FED. All right, we shall form our equation. Okay, we shall form our equation. It's the bigger arc solving for x first. Solve for x. We have 360, the bigger arc, 360 minus 111x minus, okay, 111x, the smaller arc. Then we divide this by 2. This will be equal to the angle, okay? And our angle is 70x minus 1. 70x minus 1 there, okay? And then we shall provide this with a divide there. All right, so this is our working equation. Solve for x first. All right, let us simplify the equation. We shall start with 360 minus 111x minus 111x. Divide this by 2. And this will still be equal to 70x minus 1. Yeah. Okay, so continue with the divide. All right, so this continues with 360. Continue with 360 minus 222x. We divide this by 2, and this will still be equal to 70x minus 1. All right, the division symbol will still be there over here. All right, division now. 360 by 2 is 180. So we have 180, and then we're back to 222 divided by 2. That's 111x is equal to 70x minus 1. All right, so we shall add 111x and add 111x on the other side. This continues with 180 at the left side. Right side will now be 181x minus 1 there. All right, and so we can continue on the other side with a space. All right, this will now be, we can continue over here. All right, let's continue over there. So we shall now add 1 to both sides. Okay, add 1 to both sides. So the equation will become 180 plus 1 is equal to 181x minus 1 plus 1 there. And so the right side will remain 181x. The left side becomes 181. And this will be 181x there, like that, okay? Okay, and so we will divide this by 181. So 181 is equal to 181x. We divide by 181 and 181 there. And so our x looks like just 1, okay? There. And x is 1, okay? X is equal to 1. All right, we found our x. We can now use this formula, okay? We can now use this formula over here. We shall use this formula there, okay? All right, so to solve for the angle FED, it's 70x minus 1. So we will just continue here with measure of the angle FED with the symbol angle there is equal to 70x minus 1. So this is equal to 70 times x, that means times 1, okay? Times 1 and then minus 1, which continues to 70 minus 1, which is just 69, okay? So the final answer must be 69 degrees there, okay? So this will be our answer. This will be our final answer, okay? 69 degrees. All right, we can check and verify. There, okay. This is 69 degrees, and this must be correct. Number 6 now. Let's continue with number 6. Clear the screen and proceed to the 6th question. All right, here's the next. Find the measure of the arc or angle. This time we're after the arc KM, okay? Arc KM. All right, so this must be the arc, okay? That looks like KM, or it can either be the other one, okay? The bigger arc, all right? So, because there are 2 letters only in the circle, so it's either the bigger or the smaller, okay? Let's go for the smaller, okay? Because it's got the expression 45x. All right, but still we will still apply this theorem, okay? If 2 tangents intersect at the exterior of a circle, then the angle formed is 1/2 the difference of the intercepted arcs. All right, and so we have 1 full circle minus the 45x arc. That will be the expression for the bigger arc. So we can label this. We can label the other arc 360 minus 45x there. And so our working equation here, okay, our working equation here starts with the bigger arc 360 minus 45x. That's the bigger arc minus the smaller 45x. Okay, and then we shall divide this by 2, and this will be our equation for the angle, which is expressed 14x plus 3 there. So our working equation for x is this. So we shall solve for x first. Okay, solve for x first. All right, so before we can solve for the arc km, we need the x, because the arc is 45 times x. Okay, over here. There. All right, so we shall solve for x first. So this will continue with 360 minus, removing the parentheses now, 45x minus 45x divided by 2. And this will be equal to 14x plus 3 there. Okay, so we shall continue with the simplification of the equation. This becomes, this will still be 360. 360 minus 45 and 45, that becomes 90x. We still divide this by 2. And this will still be equal to 14x plus 3. And we still have the divide there over here. And this will now be simplified to 360 divided by 2, that's 180. And 90 divided by 2 is 45 with the x. And this will be 14x plus 3. There. Okay, solve for x. We shall add 45x, add 45x, add 45x. Left side becomes 180. The right side becomes 59x plus 3. There. Okay. 59x plus 3. All right. So we shall deduct 3 now. Subtraction property. So minus 3. And this will be minus 3. We will have, how much is that? 177 is equal to 59x. All right, continue solving for x here. This will now be, 177. Continue on the other side. Continue over here. All right, this will now be written 59x equal to 177 there. And we shall divide by the 59. Divide by the 59 and 59 there. Okay, this time is division. And how much do we get there? Are we going to get 3? X is equal to, that will be about 59 times 3 is 27 and 2. Yes, it's 3. X is equal to 3. All right, so we're after the arc. We have now the x. Our arc Km, okay, this is now for the arc. We're solving for the arc now. Okay, so we will solve for arc Km. So solve for measure of arc Km. Okay, so this is arc. We shall put the symbol there. All right. So we can now solve for the arc. Now the arc Km is equivalent to 45x. Okay, so this is equal 45x, and this is equal to 45 times 3, which is equivalent to 135. Here, 135 degrees. All right, so that's it. That's our answer. Let's verify the answer near the diagram. Okay, you can see the answer at the diagram there. All right, so that's it for number 6. Let's continue with number 7. Continue with number 7. All right, next, number 7. All right, here's number 7. Okay, we have here intersection of a chord and a tangent. Okay. All right, so we have here the theorem. All right, here's the theorem. Okay, if a tangent and a chord intersects in a circle, okay, if a tangent and a chord intersects in a circle, then the angle formed is equal to 1/2 the intercepted arc. Okay, so if a tangent and a chord intersects, all right, in a circle, then the angle formed, all right, is 1/2 the intercepted arc. Yeah, okay. Then we can put this on the clipboard. Okay. All right. If a tangent and a chord intersects in a circle, then the angle formed is 1/2 the intercepted arc. Okay. All right. So what do we mean by that? This, okay, we can see this chord, and this is the tangent. Okay. Where's the angle? It's this angle there. Okay. that angle. Okay, that angle is 1/2 the intercepted arc. Okay, so the intercepted arc is right here, this arc here, there. Okay, that arc. So it's 1/2 of that. And so for this problem, it's 156 divided by 2 gives us the measure of the angle formed by the chord and the tangent. Okay. All right. So we're asked to find the arc or angle. Okay. And the one with the question mark is the angle TSR. Okay. The angle TSR. So for our working equation, the measure of the angle TSR is equal to 156 divided by 2. Okay. It's divided by 2. There. Okay. So 156 divided by 2. So it's 78. Okay. 1/2 of that is 78. You have 75 and 3. That's 78. All right. So this is equal to 78 degrees. There. Okay. All right. Okay. So this will be our final answer for this problem. This is our answer. Check and verify. The answer will be near the diagram. There. Okay. All right. Number 8 now. So let's continue with number 8. Clear the screen. Clear the answer. Number 8 now. All right. Here's number 8. And we still have the same configuration, a tangent and a chord. Okay. But the angle in question and the intercepted arc, and we don't have the intercepted arc yet. Okay. The arc is over here. Supposed to be this arc there. Okay. All right. And so we need to get that arc first. So it's 360, one full circle. So we have 360 minus the 290. It's like that. Okay. So we will have to do a subtraction there. We will have to do the subtraction. And so this will be how much? We will get here 16 and 7. That's a 70. Yes, it's a 70. So the answer here must be 70. Okay. The difference. And so one full circle minus the given arc 290 gives us the required arc. So the 70 is the required arc intercepted by the angle MLK. All right, and we're looking for that angle. Okay, the one with the question mark. So here we're solving for the angle. Okay, the measure of the angle MLK there, and this is equal to 70. Okay, let's put the solution. Okay, let's put the solution. This will be 360, okay, minus the given arc 290. Okay, that's it. After which we will have to divide that by 2. Okay, we will have to divide that by 2 there. Okay, so we have the symbol here, angle. This is the measure of the angle MLK is equal to 360 minus 290 divided by 2. Okay, which is equal to 70 divided by 2 there, which is also equal to 35. Okay, there, 35 degrees. Okay, all right, so this we have to put a division symbol over here. 70 divided by 2 there to complete our solution. All right, so our final answer is 35 degrees over here. Let's see the answer from the computer. There. Okay, so that's 35 degrees. That goes to our number 8. Number 9 now. Let's continue with number 9. Okay, here is number 9, the same configuration, and we can still use the same theorem. Okay, if a tangent and a chord intersects in a circle, then the angle formed is 1/2 the intercepted arc. All right. So we need to get the expression, okay, for the intercepted arc, which will be related to the 70. Okay, and so the arc here, the arc that we need is the 360 minus the expression on the other arc, okay, which is 72x plus 4, like that, okay? And that's the one we can relate to the 70, okay? It's one full circle minus the other arc, okay? And that'll be the expression for this arc here, okay? And so our working equation will be 360. This will be 360 minus 72x plus 4, okay? And then we shall divide this by 2, okay? Remember, it's 1/2 the intercepted arc. So we divide by 2, and this is equal to the angle 70 there, okay? And so we shall put the divide there, the divide symbol there, okay? All right, and so we shall simplify the equation and find the answer. All right, so this is 360 minus the expression for the other arc provides us the required arc for the angle 70. Okay, and that arc, the intercepted arc, will have to be divided by 2 to be equal to 70. Okay, all right, so let's simplify the equation. We have here 360 minus 72x minus 4, and this will be divided by 2, and this will be equal to 70 there. Okay, we still put the divide symbol, and we shall simplify the equation. All right, so what do we have here? This is now 360 divisible by 2. 72 is divisible by 2. 4 is divisible by 2. So our next line, we can make the numbers smaller first. 360 by 2 is 180. 72 by 2 is 36x. The 4 divided by 2 will be 2. And this will now be 70. And we don't have a fraction now. There. All right. 180 minus 2 is 178. And we still have that minus 36x. This is equal to 70. All right. Okay, so we can do transposition here. We put the 36x to the right, we put the 70 to the left, changing the signs. So the next line will be 178 minus 70, and the right side is 36x, like that. Transposition, okay? Put the 7 to the other side, change the sign, put the 36x to the other side, change the sign. And so the left side is now 178 minus 70, resulting to 108, and it's equal to 36x. Okay, dividing both sides by 36. Okay, we will divide both sides by 36. So this is 108. We shall do the solution on the right side of the screen. We shall continue there. Okay, we can write 36x. 36x is equal to 108 there. Okay, symmetric property. And divide this by 36. Divide this by 36 there. All right, so this provides us the answer. All right, this will be 108 divided by 36 is exactly 3. Yes, x is equal to 3. Yeah. 18 and a 10, yes. That's 18, carry 1, 9, and 1, 10. All right, so that's exactly 3. We're asked to solve for x here. Here, solve for x. So final answer, x. Okay, that's it. You can see the answer below near the diagram. So this must be correct. Number 10 now. Let's continue with number 10. Let me clear the screen. We're doing number 10. All right, here's number 10. We still have the same configuration, tangent and a chord. All right, so we can have the same theorem. All right, if a tangent and a chord intersects in a circle, then the angle form is 1/2 the intercepted arc. All right, we have here 170, the arc, divided by 2. So 170 divided by 2 must be equal to the angle expressed 8x plus 5, like this. Okay, this will be this will have an equal sign there. Okay, so just clarification, 170 divided by 2 is the arc intercepted by the angle 8x plus 5. And we're after x here. All right, solve for x here only. So it's a 35 and 50, 35 and 50, that's 85. Yes, 85. All right, so we have here 170 divided by 2, that's 85. Okay. Yes, 85, and that's equal to 8x plus 5. All right, continue with subtraction. Subtract by 5 and subtract by 5. And we get like 80 is equal to 8x. And we shall divide 80 by 8. So this is divide by 8 and divide this by 8 there. And we get the value of x. And x is equal to 10. Yes, x is equal to 10. Yeah. All right, so that's it. 85 and 85. And yes, all right, so x is equal to 10. Let's see the answer. Check and verify. Yes, it's 10. There. All right, so that'll be for number 10. All right, we're asked to find x only. Number 11 now. Let's have number 11. Clear the screen, and then number 11. Here is number 11. The same configuration, a tangent and a chord intersecting in the circle. But this time we're after the angle SRQ. Okay, where's angle SRQ? SRQ is over here. This angle here, SRQ. So our equation here will be involving the arc, okay, which is formed by the intersecting tangent and a chord. And we can get that first, okay? And that arc, okay, will be right here. And that'll be 360 minus the other arc, which is marked 8 plus 63x. There, okay? All right. Remember, the arc expressed with 8 plus 63x is the other arc, and that's not related to the required angle. Okay, so to get the arc related to the angle with 14x minus 6, that is the SRQ, we need to subtract 8 plus 63x from 360. Okay, so that will be our working equation, and then we still have to divide this by 2. So this is our working equation now. Okay. All right, we shall start with the arc, 360 minus 8 plus 63x. There. We shall divide this by 2. And this relates to the angle SRQ, which is 14x minus 6. There, okay? All right, and so this is divide, okay? This is divide over here. There, okay? All right, so we shall simplify the equation to get x and then solve for the angle. All right, so we shall solve the angle after we get the x. All right, so this will continue with 360, okay? 360 minus 8. This is minus 63x, okay? And this continues with 14x minus 6. And we still have to divide the left side by 2. Like this. So that removing the parentheses will give us minus 8 and minus 63. So this will continue this way, and then we can simplify this. We have 360 minus 8, that should be 352. Yes, 352 there. And we still have the minus 63x and this will still be divided by 2. And the right side is 14x minus 6 there. So we shall get rid of the fraction. We shall get rid of the fraction, okay, by multiplying by 2, okay. We shall multiply by 2 both sides, okay. So multiply this by 2 at the left side. We have something like this. All right, enclosing it in parentheses like this, and then multiply this by 2. We have here times 2, and then times 2 here. Okay, we put the asterisk here, say times 2 like this. Okay, this 2 cancels out. Okay, this 2 and this 2. All right, so we have the left side at 352 minus 63x must be equal to, how much is that? 28x minus 12. There. All right, simplification. We shall add 63x plus 63x, and it follows we will have 352 is equal to, how much is that? 11 and 1, that's 91x. Yes, minus 12. There. 11 carry 1, and that's 91x. And then, all right, we add 12 to both sides. Add 12 here. And add 12 at the right. Left side becomes 364. And this is equal to 91x. There. All right. I hope it's divisible, okay? So 364 is equal to 91x. We divide by 91. Divide by 91 and divide this by 91. All right, what do we have there? It looks like 4. Okay, so this is divide, and 4 is the answer. Okay, yes, x is equal to 4. So first we will write it. We will write it 4 equals x. Okay, 4 is equal to x, and then symmetric property allows us to write x equals 4 there. Okay, so we found our x. We can now solve for the angle. Our angle is SRQ. Okay, SRQ. We shall solve for the angle. All right, this will be the measure of the angle SRQ is equal to 14x minus 6. 14x minus 6, and this is supposed to be angle. Okay, yes, the symbol is angle there. All right, so solve. Substitute the x there. This is equal to 14. 14x minus 6 means 14 times x. That means 14 times our x, which is 4, minus the 6. So how much do we get there? This will be that'll be 16, and that's 56. Yes, 56 minus 6. That looks like 50. Okay, our answer is 50 degrees. There, our answer is 50 degrees. All right, so this will be it for number 11. Let's check the answer and verify. Yes, it's 50. There. All right, so that goes to our number 11. Number 12. Let me clear the screen. Continue with number 12. All right, here's number 12. Okay, we have another tangent and a chord. We will still apply the theorem. Tangent and a chord intersects in a circle. The angle formed is 1/2 the intercepted arc. Okay, so before we can relate the negative 1 plus 38x, we need to get the expression of this arc there. Okay, that arc I marked red. Okay, and that should be related to the 104x plus 2. Okay, and so we shall express this arc that I marked red. Okay, this must be expressed like 360 minus the 104x plus 2 there. Okay, all right, so the 104x plus 2 is the arc expression, the expression for the other arc, which is not related to the uh, arc PQ. Okay, the measure of the arc PQ. We're after the arc PQ. Okay, all right, and so we shall express the arc PQ as 360 minus 104x plus 2. Okay, all right. So let us solve that particular arc there. All right. So we're after the measure of the arc PQ. All right. So let's do that. Okay. Examining the arcs. Okay. The given expression 104x plus 2 is the bigger arc. Okay. Which can also be called arc PQ. Okay. Remember, there are only two letters in the circle. So it's either the bigger arc or the smaller arc. Okay, so we shall solve both arcs. Okay, we shall solve both arcs because there are only two letters in the circle. So it's either the bigger arc PQ or the smaller arc PQ. Okay, so the question is not definite. Okay, because there are two arcs we can name PQ there, the bigger and the smaller. Okay, all right, so let us solve both arcs. Okay, all right, so we can have the solution starting with that 360 minus 104x plus 2. Okay, that's the one we can relate to the angle. Okay, that's the one we can relate to the angle after dividing by 2. Okay, all right, there. Okay, and so this is equal to negative 1 plus 38x, which is the expression for the angle. Okay, the expression for the angle. So this will be difference in arc divided by 2. Okay, there. So, all right, so we can solve for x first. All right, let us solve for x first here. All right, so let's do that. We have something like 360. All right, we have 360. Let's remove the parentheses. This is minus 104 x. Okay, and then that becomes minus 2, and this will still be divided by 2. Yes, there. All right, so this will still be divide. Let's continue with the right side, and this is equal to negative 1 plus 38x there. Okay, so let's put the divide symbol. Let's make the numbers smaller. These are all divisible by 2. So 360 divided by 2 is 180. The 104 is divisible by 2. That'll be 52x. And the 2 is divisible by 2. Of course, that becomes 1. Okay, I think there is, all right. This will be a minus 1 there and plus 38x. All right. Okay, so sorry for that extra equal sign. Okay, that should not be there. This equal sign there. Okay, that will just be a minus. Okay, that will just be a minus. Yes, this one. This will be a minus there. All right. Yes, I typed an extra equal sign. So that will just be a minus 1 plus 38x. All right. After dividing by 2, the left side is now 180 minus 52x minus 1. Okay, dividing all the numbers by 2. All right, so let's simplify it. Okay, this minus 1 and minus 1, okay, cancel each other. Okay, this negative 1 here and negative 1. Okay, this cancels to 0. Okay, so we can just add 52x. Okay, add 52 here. So we add 52x and we add 52x there. All right, so continue with the next part of the equation. We have 180, and this is equal to, how much is that? 10 carry 1, that gives us 90x at the right side there. 38 plus 52 is 90, okay, there. So that's a 90x. All right, so looks like our x is just 2, okay, after dividing by 90. So we shall divide this by 90 and divide this by 90. And we will find our x. So this is divided by 90, this is divided by 90, x is equal to 2. So the value of x is 2 there. All right, so we got our x. We can now solve for the arcs, okay? All right, there are 2 arcs, okay? There are 2 arcs here. All right, the one with the expression is 104x plus 2, okay? That's also PQ. And the other one, I marked 360 minus 104x plus 2. That is also, that can also be called PQ. All right, so there are 2 arc PQ here, arc PQ. All right, so let us solve the smaller and the bigger, and okay, that will be, those are the 2 arcs with the name PQ. Let us start with the given 104x plus 2. Okay, let's solve that one. Okay, because there's ambiguity here. Okay, all right, because there are only 2 letters in the circle. Okay, the letter R is a point not on the circle, so there are 2 arc PQs there. All right, so let us go for the one with the expression. Okay, all right, so let us solve that first. Okay, so this will be the measure of the arc PQ, okay, is equal to, let's use the 104x plus 2 there, okay. And this will be equal to 104, okay. 104 times x, okay, so this will be times 2 plus 2 there, okay. And this will be equivalent to 208. This is 208 plus 2. Okay, multiplying 104 by 2. Okay, multiplying it by 2 gives us 208, and we shall add 2. That looks like 210, and this is equal to 210 degrees there. Okay, all right. Okay, the other arc PQ, remember this is the arc. Okay, this is the arc PQ with a given expression. It's 210. Okay. Now, if we will get the other arc PQ, all right, which is related to the angle, okay, that's another arc PQ. All right, so we're going to solve both of them. Okay, this is another arc PQ, which is also equal to 100, and this will now be the other one, 360 minus 104 plus 2 there, okay. But we already know 104x plus 2, that's 210. So that means this is 360 minus 210 there. And so this will be about 150, okay. So this is equal to 150 degrees, okay, there. Okay, so this is also the arc. This is the minor arc, okay, there. All right, because the question arc PQ can be 2 arcs, okay. It's either the bigger or the smaller because there are only 2 letters PQ. All right, so either of the 2, okay, is the answer. All right, okay, it's either 210 or 150. 150. Okay. All right. So let us see the answer. All right. Let us see the answers. All right. So there's only one PQ for the answer, but it's either the 210 degrees or the 150 degrees, of which the total is one full circle, 360. Okay. All right. So let's check and verify. It's 150. Okay. All right. We're asked to get the uh, arc related to the angle. Okay. So it's 150 there. So this is the required arc there. It's 150 degrees. All right. Okay. As you can see over here, stated by the computer, okay, it's the smaller arc that I marked red. Okay, there. Okay, so it's 150 degrees. All right, so that's it. That goes to our number 12. Let's continue with number 13. Let me clear the screen. So this will now be for number 13. All right, here is number 13. Okay, this time we have a secant and a tangent. Okay, a secant and a tangent. All right, so we're asked to find the measure of the arc or angle. And still we still have a theorem for this. Okay, if a tangent and a secant intersect at the exterior of the circle, the angle formed is one half the difference of the intercepted arcs. So here's the theorem. Okay, so here's the theorem. If uh, a tangent and a secant intersect, if a tangent and a secant intersects, all right, outside the circle at the exterior, if a tangent and a secant intersects at the exterior of a circle, then the angle formed is equal to one half the difference of the intercepted arcs. That's arcs there. Okay. All right. So put this in the clipboard. Okay. So we can use it in the succeeding questions. If a tangent and a secant intersects at the exterior of a circle, then the angle formed is equal to one half the difference of the intercepted arcs. Difference of the intercepted arcs. Okay. All right. So what do we mean by that? Okay. It will be from the diagram itself, so we don't have to draw it. Okay. This angle, the measure of this angle, okay. Remember, this is the tangent. We can see the tangent here. Okay. There's the tangent, and here's the secant. Okay. All right. And the angle over here, which is the 36, okay, is equal to one half the difference of the intercepted arcs. It's this arc minus this arc divided by 2 is equal to 36. It's like that. Okay. All right. Okay. So again, all right, it's like this. This arc minus this arc divided by 2. That's equal to 36. It's like that. Okay. All right. So let's solve it. All right. It will be this way. Now, the question here is, of course, not the angle. It's the arc with a question mark there. And we shall label it X. Okay. We shall label this X. So if this is labeled X, then our working equation will be like this. Okay, here's our working equation. X okay, x minus the other arc 114, okay, divided by 2 is equal to 36. There, okay, here's our working equation. Okay, this will be our working equation. So it's just solve for x here. All right, so multiply both sides by 2. So we're going to simplify this. Okay, we shall start with 2 times, all right, we have x minus 114. Okay, and this will be divided by 2. There, okay, it goes like this. And this is also times 2. 2 times 36, like this. Okay, this will be the next line. Okay, there. So it's just that the first equation, the first line, multiply by 2. Okay, both sides. And what happens will be like this. Okay, this 2 divides this 2 divides by the other 2, and the right side becomes 72. So this continues with x minus 114 is equal to 72 there. So we add 114 and we add 114, and we will find the x, which is equal to how much is that? 186. This is 186 degrees there. And this will be our unknown arc with a question mark. Okay. All right, let's find the answer. Okay, it's 186 over there. And that'll be for number 13. Let's continue with the next number, 14. Number 14. All right, here's number 14. Same configuration with a tangent and a secant. Okay, tangent and a secant. All right, so we're looking for the angle. The angle is the one marked with a question mark. And you can call that angle KLM. Okay, angle KLM. All right, so we will just write, for simplicity, let x be equal to the measure of the angle KLM. Angle KLM there and there. Okay. For simplicity, let x be equal to the measure of the angle KLM. All right. So our working equation here will be the bigger arc 155. Okay. It will be the bigger arc 155 minus the smaller arc 45. Yes. Divided by 2 must be equal to the unknown angle x. There. Here's our working equation. Okay. There. All right. So the next line will be 155 minus 45. How much is that? That'll be a 0 and 1 and a 1. 110. Yes. And then this will be divided by 2. And that equates to x. This will still be divided there. 5 minus 5, 0. 5 minus 4, 1. Bring down 1. So x is just 55. Okay. X is just 55 degrees there. And that's it. Okay. All right. So what's the answer from the computer? You can see it near the diagram there. Okay. There. So this must be correct. Yeah. Okay. All right. So I hope you're getting the way to get the solution. Okay. All right. So number 15 next. Number 15. Here's number 15. All right. So we still have one tangent, one secant. We still apply the same theorem. We still have the same theorem here, tangent and a secant. And our working equation will be the bigger arc. Okay, that's 105x minus the smaller arc 80 divided by 2 is equal to 65. There. So this will have a divide symbol here, divide there. Okay, this is our working equation. And we're asked to find x only, okay? Find x. So we shall begin by multiplying both sides by 2, okay? By multiplying both sides by 2. So we will just rewrite this with multiplication by 2. So 2 times 105x minus 80, and then we have that divide by 2, and then that equates to 2 times 65 there, okay? All right, so it's just the first line multiplying the first line by 2 there, okay? All right, so multiplying both sides by 2, becoming this way, and then we have 105x minus 80 is equal to 130 there. Okay, next line is add 80, and add 80 there. All right, so next line becomes 105x, and this is equal to 200. How much is that? 11 carry 1, 210. Yes, 210. Yes. Is that divisible? That looks like, yes, that's divisible. So we can divide now by 105. Okay, we can now divide by 105. All right, so we're just after x here. We can continue with the right side of the screen. All right, so continue at the right side. This will be 105x is equal to 210. We divide by 105, and we divide this by 105 there. All right, so this will now be dividing both sides by 105. All right, so that looks like x equals 2. X is just equal to that's it, and that's our answer. Let's verify from the computer. See the answer below the diagram there. Okay, all right, you can see it there. Number 16. Let's continue with number 16. All right, number 16. All right, here's number 16. All right, the same diagram. We have one tangent, one secant. We can still follow the same theorem. Okay, let's rewrite again the theorem there. Okay. Okay, so this will now be the bigger arc 177. Let us write the working equation. It will now be the angle form 3x plus 8 must be equal to 1/2 the difference of the arc. All right, 177 minus 107, all right, and this will be divided by 2. There, okay, so 177, this will be divided by 2, there. So 177 minus 107 divided by 2, that's equivalent to the angle formed at the exterior by the tangent and the secant. All right, solve for x only. So let us simplify first. 177 minus 107, that will become 0. That looks like 70, okay? Yes, subtracting 107, that will be 70. So the right side is 70 divided by 2, okay? So we still have 3x plus 8 is equal to 70 divided by 2. There, okay? This is divide. There, there's a divide there. 7 minus 7, 0. 7 minus 0 is 7. 1 minus 1 is 0. So it's 70 minus 70 divided by 2. So we have the next line, 3x. This will be 3x plus 8 is equal to 35. Then we subtract the 8. Subtract 8 and subtract 8 there. And so we have 3x, that's equivalent to 27, okay, 27. And this is exactly divisible by 3. Looks like x is 9, okay? All right, so we will have here divide by 3 and divide by 3, and we will get the answer 9, okay? You'll be able to get the answer 9. So x is equal to 9 here. X is equal to 9 there. All right, let's check the answer. Yes, all right. So you can see the answer below the diagram there. So this means this is correct. Number 17. Let's continue with number 17. All right. Here is number 17. Okay, from the diagram of number 17, we still have another tangent. We still have another secant intersecting outside the circle. So we can still follow the same theorem here. Okay, so we're asked to get the measure of the angle UTR. UTR. So we're after this angle there. Okay, what's the measure of UTR? So we're going to use the 1 plus 16x. Okay, the 1 plus 16x. So we shall make our equation the bigger arc minus the smaller arc. Okay, let's start there. All right, so the bigger arc is 47x plus 6. Okay, this is the bigger arc there. And then minus the smaller arc 64, then dividing this by 2. Okay, this is equal to the angle, okay, 1 plus 16x. 1 plus 16x. There. That's the expression for the required angle UTR. So here's our working equation with a division here, of course. Solve for x first before we get the angle UTR. Okay. All right. So let's see what we can do in the equation. So this is 47x, removing the parentheses, minus 64. And then what do we have there? We still have the divided by 2. And then this is equal to 1 plus 16x, okay? And then we still have the divide, okay, over there. All right, 47 is not divisible by 2, okay? So we shall multiply both sides by 2. So we put a number 2 here. 2 times, and there will also have there will be a 2 times here. All right, so we put a parenthesis here first. Okay, we put a parenthesis here because this is one group, and then this continues with times 2 also. Okay, times 2 there. Okay, and so this number 2 cancels out. This 2 cancels out with the denominator of the fraction. All right, so next line we have 47x. Okay, the 6 minus 64 is a minus 58, like that. And so the right side to be multiplied by 2, we have 2 times 1, and 2 times 16, that's 32x. There. All right, we have a simpler equation. Solve for x. Okay, let us start with subtracting 32x from both sides. Subtracting 32x there. All right, so we get like 15x at the left. Okay, 15x, 7 minus 2, 5, 4 minus 3, 1. We still have that minus 58. And the right side is just 2. All right, add 58 now. Add 58 and add 58. We get the left side the same, 15x. And the right side is now 60. There, all right, of which we will get x now 4. And x is equal to 4, okay? All right, after division by 15, x is 4, okay? All right, so we will not do a shortcut, okay? We shall continue to the other side, okay? We will continue to the other side. Let's put just an arrow going up, okay? Going here, okay? All right, there. And we shall continue there. All right, we will write 15x equals 60. We will divide by 15. Divide by 15. And this will now be 4. Yes, like what I said a while ago, it's a 4. So x equals 4. Yes. That's our x. All right, and so we're solving for UTR now. UTR is 1 plus 16x. All right, so angle UTR, solve for angle UTR. All right, so the angle UTR is expressed, okay, 1 plus 16x, okay, 1 plus 16x. Okay, this is equivalent to 1 plus 16 times x, but our x is 4. There. So we have 1 plus 64, okay? 1 plus 64, which is 65. So our answer is 65 degrees, okay? That's our answer, all right? 65 degrees, okay? Check and verify. We shall see the answer. There, 65 degrees, right? As displayed by the computer. All right, there. Let's proceed to number 18. Continue with number 18. Okay, here is number 18. All right, what do we have here? We still have a tangent and a secant. Okay, okay, you can see a tangent here. You can see a tangent here. All right, and here's the secant there. So we can still use the same theorem there. That's the same theorem. All right, so we shall apply it here. And a tangent and a secant intersects at the exterior of circle, then the angle form is equal to half the difference of the intercepted arcs. Okay, so how about the arcs, and which one is the requirement? Find the measure of arc BRE. Okay, BRE. So where is BRE? It's BRE. Oh, it's the larger arc. We're asked to get the larger arc, BRE. And so this larger arc is actually equivalent to 17x minus 5. There's a given expression. It's given. It's over here. There. It's 17x minus 5. That's BRE. Okay. So it's the larger arc. Let's have our working equation. Okay. Here's our working equation. It's the larger arc 17x minus 5. Okay. This is the larger arc. There. Okay, minus the smaller arc. Our smaller arc is expressed 9x plus 17. There. And then we divide this by 2. And this equates to the angle expressed 3x. There. Okay. All right. So we put here divide. This is our working equation for x. Okay. Solve for x first. All right. Removing the parentheses. This will now be 17x minus 5 minus 9x minus 17. Okay, divided by 2 equates to 3x, and this will still have the divide symbol. All right, combining like terms. All right, what can we combine there? 17x minus 9x is 8x. Okay. So this is 17 minus 9 is 8x there. And then negative 5, negative 17, that's a negative 22. And this will still be divide by 2. And this is equal to 3x there. All right, so this will now be with the divide there. All right. Okay, the 8 and the 22 is exactly divisible by 2. And so we can continue here with 4x. 8 over 2 is 4x, and this is minus 11. There, 8 by 2 is 4, 22 by 2 is. All right, so this is equal to 3x. And all right, we shall do just transposition here. Okay, interchange the 11 and the 3x. So this will remain 4x. This will become minus 3x, and the 11 goes to the other side, making it positive. there. Positive 11. Yes, there. Okay, so the left side becomes 4x minus 3x, which is x, equal to exactly 11. That's our value of x. That's 11. Now we're ready to compute the measure of the arc BRE. Okay, so we will do it the right side. Okay, the measure of the arc BRE. So this is measure of the arc BRE is equal to 17x minus the 5. Okay, and we'll put the symbol for the arc. Okay, supposed to be arc there. All right. Okay, so we substitute our x now in place of x. So this is 17 times 11 minus the 5. Okay, and how much is that? 1717187. Okay, so this will be equal to 187 minus 5. Yes, all right, so that will be 182. Okay, final answer. And this will be in degrees. That's our final answer. This will be our final answer there. It's 182 degrees. All right, so that's it. Let's check and verify. Check the answer below the diagram. It's 182 degrees as displayed there. This is correct. All right, number 19. Let's continue with number 19. All right, number 19. Okay, here's number 19. We have a different diagram here. Okay, two intersecting chords. If two chords intersect inside a circle, then the angle formed is equal to 1/2 the sum of the intercepted arcs. Okay, all right, so sum. Okay, sum. All right, so here's the theorem. We have a different diagram here, so this will be the theorem. Okay, this is the theorem. All right, if two chords intersect, all right, if two chords intersects inside the circle, then the angle formed, all right, is equal to 1/2, okay, to 1/2 the sum, okay, 1/2 the sum of the intercepted arcs. There, okay, all right. Put it in a clipboard, okay, there. If two chords intersects inside the circle, then the angle formed is equal to 1/2 the sum of the intercepted arcs. Okay, if two chords intersects inside the circle, then the angle formed is equal to 1/2 the sum of the intercepted arcs. Okay, the sum of the intercepted arcs. Okay, 1/2. So it's the average. Okay, it's the average of the two arcs. Okay, all right. And so for this problem, okay, what do we have here? We're looking for the arc here. Okay, we're looking for the arc here. It's supposed to be this way. This arc plus this arc divided by 2 gives 74. Okay, there. It's supposed to be like that. So if we shall mark the unknown, all right, let's remove my drawings there. If we shall mark the question mark arc with the x for simplicity, all right, then we have the equation this way. X plus the other arc 65 divided by 2 must be 74. There. Okay. Here's our working equation. This will be our working equation. Okay. All right. So we shall rewrite this. All right. Let's just rewrite it. Okay. And multiply both sides of the equation by 2. So it's 2 times, okay, x plus 65 equals 2 times 74. Okay. And we still have the divide here. Okay. There. Supposed to be this way. There. So it's the first given equation, okay, multiplied by 2, okay, times 2 to both sides. So this cancels out. This 2 here and this 2 here. And the left side will just be x plus 65. So this will be x plus 65, which is equal to, how much is that? 148. Okay, and then we will do this by way of subtracting 65 and subtracting 65. And so x is equal to, how much is that? 8 minus 5 is 3, 14 minus 6 is 8. There. So this will be our answer, 83 degrees. Okay, that will be it. Check. There. All right, you can see the answer over there. Number 20. Let's continue with number 20. All right. Let's continue with number 20. All right. Okay, here's the next. All right. We'll mark the unknown angle x, all right, over there inside. And we have our working equation, the bigger arc, 210. Okay. The bigger arc, 210. Remember, it's these are intersecting chords inside. Okay. So 210 plus the 50 divided by 2 is equal to our x. Let's put the x on the other side, okay? Let's put the x here. We can put it here. All right, x is equal like that, okay? So it's already at the left side, okay? The average of the two arcs, intercepted arcs, will be the angle formed by the intersecting chords. So it's 210 plus 50 divided by 2. So our next line will be x, which is equal to 260 divided by 2, okay, which is 130. So x is equal to 130 degrees. There. And so we can check and verify the answer. It's 130 there. All right. Okay, number 21. Let's proceed to number 21. Okay, here's number 21, the same configuration, two intersecting chords. Our working equation will be the angle 129x is equal to the sum 207x plus 1 plus the other arc 50. We shall divide this by 2. And that's it. All right. We divide this by 2, and this is our working equation. All right, there. Okay, so we shall solve for x here, okay, as required. There, solve for x. Okay, so what do we have here? We shall multiply both sides by the 2, okay? All right, so we shall multiply both sides. So we have 2 times 129x is equal to 2 times, okay, we have that quantity 207x plus 1 plus the 50 and divided by 2 there, okay? And so the 2 and the 2 divides, okay, we have a simpler equation here. So what is this equal to? This is 258x. This is 258x. Yes, times 2, 18 and a 5 and a 2, yes. Yes, and then the right side is 207x plus 51. And so we shall subtract the smaller 207x. So this will now be minus 207x minus 207x. And we shall get how much? We shall get there 1 and we shall get there 51. Yes, 51. 51x. And the right side is just 51. And so we will continue by division by 51. So divide both sides by 51. So 51x is equal to 51. We divide by 51. We divide by 51. There. Okay, for a clearer solution, our x is 1. Okay. X is equal to 1. Okay. That's it. All right. And let's check and verify from the diagram. You can see the answer below it. There. Okay. You can see the answer over there. So this is correct. 22 now. Let's continue with 22. All right. Proceed to number 22. The 22nd question. Okay. The same configuration. Okay, we can still apply this theorem. If two chords intersect inside the circle, then the angle formed is equal to 1/2 the sum of the intercepted arcs. All right, observe the angle. The angle is 14x plus 3. So our working equation is 14x plus 3. This is equal to the sum 105 plus 125 divided by 2. Okay, there. So this is our working equation. Solve for x. Okay, so we still have 14x plus 3. This is now 200. How much is that? 230. Yes, 230 divided by 2. Okay, yes. 230 divided by 2. And so we still have a division symbol here. And we're going to have 115. So our next line is 14x plus 3 is equal to 115. Okay, 115. So we deduct 3, minus 3, and minus 3. And next line is 14x, and this will now be 112. Okay, will that be divisible? So how much is that? 8. Yes, 8. All right, 14x. We shall divide this by 14. And we shall divide this by 14. Looks like 8. So x is equal to 8. Okay, x is equal to 8. That's 32, and then 3, that's 11. Yes. All right. How about the answer? There. This means correct. All right. So that goes to our 22. Let's proceed to number 23. Let's continue with number 23. All right, number 23. Okay, we still have two chords intersecting inside the circle. So we can still apply this theorem. Okay, and so our working equation will be the angle 9x minus 9. You can see the diagram for the angles and chords and arcs. Our angle is expressed 9x minus 9. That's the angle. Okay. Our two arcs will be added. So this is 8x plus 7. We will add the 65 arc, and we shall divide this by 2. There. And this is our working equation. All right. This will be our working equation. Okay. So we shall simplify it. Left side is 9x minus 9. And we continue with 8x plus, how much is that? That's 72, okay? Plus 72. 65 plus 7, that's 72. All right, we still have to divide this by 2, okay? We divide this by 2, and we put the division symbol right here. All right, so left side is 9x minus 9. So this is 9x minus 9. This is 8x divided by 2 is 4x. 72 by 2 is 36. There. All right, so we subtract 4x from both sides. And left side becomes 5x minus 9. Right side will just be 36. We proceed by addition of 9, plus 9, and plus 9. Left side becomes 5x. Right side becomes 45. And x looks like 9, okay? All right, x is 9 after division by 5. We divide by 5. All right, so we will complete our solution, and we will write our x equal to 9, okay? All right, we'll just put it at the bottom. Okay, we'll just put it here, put an arrow there, and x is equal to 9. X is equal to the value 9. All right, we shall compute for the requirement. Okay, at the right side space, we're asked to get the measure of the angle DCE. Okay, find the angle DCE. Okay, all right, so the angle DCE is the 9x minus 9. Okay, this is equal to 9x minus 9. All right, so this is equal to 9x. That means 9 times 9 minus 9. And so this is equal to 81 minus 9. Okay, there. Okay, so this is equivalent to 72. Okay, all right, so this is equivalent to 72 degrees. Yeah, okay. 11 minus 9 is 2. Bring down the 7. All right, so that's it. That's our answer, 72 degrees. Check and verify. We can check and verify the answer. Yes, okay. There is the computer's answer. Here's our answer. All right. You can study the solution, okay, so that if you encounter this configuration, 2 chords intersecting inside, and you're asked to find angle or arcs, then you know how to do it. All right. Let's continue with the 24th. Let me clear the screen. Number 24. All right, here's number 24. We still have the same configuration. 2 chords intersecting. We have the theorem. Okay, our formula will be, okay, the arc 7x minus 7. Okay, all right, this arc plus this arc divided by 2 is this angle there. Okay, all right, so our working equation will be, let's get the 7x minus 7. Okay, this arc plus the other arc 160. Okay, all right, divided by 2. All right, divided by 2. All right, divided by 2. This is equal to the angle 10x plus 5. 10x plus 5. There. All right. So this will still have a divide. Okay. This will still have a divide there. Okay. All right. So we add the arcs, divide by 2. That's equal to the angle formed by the 2 chords. All right. So let us simplify first. What do we get here? Let's simplify first. Let's remove the fraction, okay? Times 2. So let's multiply this by 2 right away. Okay, times 2 here. Okay, all right. And then times 2 the right side. Let me put a number 2 here after putting a grouping symbol. Okay, let's do times 2 there. over here. So times 2 there. Okay. All right. So this number 2 cancels out. Okay. This 2 and this 2. And so we have a reduced equation 7x minus 7 plus 160 is equal to the right side will be that will become 20x, and the 5 and 2 becomes 10. All right, so we don't have a fraction anymore. All right, so this continues with 7x. This will be 153. 160 minus 7, that will be 153 is equal to 20x plus 10. Okay, combining like terms, we subtract the 7x. Okay, subtract 7x, and then subtract the 7x. All right, so what do we get there? We will have the left side 153. The right side becomes, how much is that? 13. Yes, 13x plus 10. And then we continue by subtracting 10. Okay, minus 10 and minus 10. Minus 10. All right, so this gives us, how much is this? 143 is equal to 13x. Okay, will that be divisible? Will that be divisible? That's 1 and 1. Yeah, that looks like 11. Okay. All right, so we shall continue by division. This can also be written 13x equals 143. Okay, there. And so we can continue over here at the right side. We shall continue at the right side, 13x. It should be 13x is equal to 143. We divide by the 13, and we divide by the 13. We put a division line there, and x is equal to 11. Yes, 13 and 13, that's 143. Yes, all right. So x is equal to 11. X is equal to 11, and we found our x. We can now solve for the arc NC. Okay, arc NC. So we'll put the solution below this. Okay, we put a line there. We're now solving for arc, NC. Okay, NC. All right. This is for the arc. There. All right. So the equivalent of arc NC is 7x minus 7. Okay. So this is equal to 7x minus 7. This is equal to 7 times 11 minus 7. And so this is equal to 77 minus 7, which is just 70. Okay. Answer is 70 degrees. That's our final answer. Okay. All right, let's verify our answer from the computer. It's 70 as displayed here. This must be correct. Okay. And that's the measure of the arc NC. Okay. All right. Number 25. Let's continue our solutions. 25 now. Let me clear the screen. Proceed to number 25. All right. Here's number 25. All right. What do we have here? Okay. So let me explain this. Okay. If we have a circle, and a chord and another chord intersecting, okay, and we have this arc, okay, all right, so we have this particular arc here, okay, let's put labels, okay, let's put labels. So if this is A and this is B, and this is point C, and this is point D, over here, and let's mark the intersection as point O there. All right, so here is our diagram. Okay, here is our diagram. All right, the arc AC, the arc AC. All right, this is our arc AC. All right, so arc AC plus arc BD divide this by 2 gives the angle AOC. Okay, this is equal to the angle. All right, let me write that. This is equal to the measure of the angle AOC. Okay, AOC there. Okay, all right, this angle. Okay, imagine if your arc BD disintegrate to 0. Okay, if your arc BD becomes 0, then the picture will be like the number 25 diagram. Okay, imagine this arc here becomes 0. That means they will merge to 1 point. Okay, the B and the D will merge to 1 point, and so the picture will now be like this. The picture will now be like that. There. Okay, that'll be the picture. Okay, that'll be the picture, and your angle AOC will still be AOC, which will still be this angle here. There. Okay, there. And so the formula, the same formula, you will just make BD 0. Okay, so this is now 0 there. Okay, this arc BD is now 0. And so if this is 0, then you have uh, the arc AC divided by 2. Okay, our equation now is the measure of the arc AC divided by 2 will still be the angle AOC. Okay, and it becomes an inscribed angle. Okay, it becomes an inscribed angle, and so this arc here divided by 2 is the angle here. Okay, you're going back to the inscribed angle. Okay, but still the same formula is applied. Okay, these are still two intersecting chords, only they intersect at the same time in a point on a circle at a common point, becoming the inscribed angle. So that means the arc is 2 times the angle, or the angle is 1/2 the arc. Okay, all right, so that means we have a simpler solution. Okay, that means our arc there is 2 times the 45. So our arc there is 90. Okay, this arc is 90. So our arc with a question mark is arc PR is just 2 times the 45, which is equal to 90 degrees there. Okay, all right, that's the answer. It's 90 degrees there. Find the measure of the arc. Arc is 90 there. And this is correct. Okay, all right, let's continue with number 26. Let's continue with number 26. All right, here's next number 26. All right, here's number 26. And still, our configuration became just inscribed angle. So the angle there with the question mark, which is angle TUV, the angle TUV is equal to 1/2 of the arc. That is 130 divided by 2. Our answer must be 65 degrees. That's the answer. Okay, all right. Check and verify. There. All right, so this is correct. Proceed to number 27. Number 27 is this. All right, here's number 27. Okay, all right. We still have an inscribe angle here, inscribe angle. That means our arc is x plus 130. Let's type it. Okay, we have x plus 130. We divide this by 2, and this equates to the 65. Okay, there. This equates to the 65. All right, and we will solve this, multiply both sides by 2. So times 2 here. So this will be 2 times x plus 130 equals 2 times 65. And we still have the over 2. Okay, we still have the over 2 here. There. Like that. And so if we multiply both sides by the equation, it will look like this. And the 2 cancels out there. And the left side is left x plus 130, and this is equal to 130. Okay, this is equal to 130. And so if we solve for x is just 0. There. Okay, x is just 0. Let's verify the answer. There. Okay, you can see it at the bottom of the diagram. The answer is 0. Number 28. Continue with number 28. All right, next number. All right, here's number 28. We still have an inscribe angle here, okay? Inscribe angle. All right, so we have here our working equation. We will have the angle x plus 37. That is equal to 1/2 of the 74, or 74 divided by 2. Okay, the arc is the 74. If you divide that by 2, that's the measure of the inscribed angle. So we're asked to solve for x here. So we have x plus 37. This is equal to 1/2 the 74. So that will be about 30. How much is that? 38. Yes. 30. That's yes, 38. No. That looks like 37. Yes, 37. 37 times 2 is 74. Yes, all right. So that's 37. And looks like we have another 0 here, okay? 14 and 7. All right, so subtracting 37 from both sides, this will be minus 37, minus 37. X is just 0. All right, we have another 0, okay? We have another 0. All right, let's verify the answer. Is it 0? Yes, it is. All right, so that's it. And our answer is correct. 29. Let's do number 29. All right, let's continue with number 29. All right, here's number 29 drawing. Okay, we still have a case of 2 intersecting chords, but one arc is 0. Okay, one arc is 0. And so it is reduced to an inscribed angle. All right, here's our working equation. So we have the arc 17x plus 13, dividing this by 2. This equates to the angle, and the angle is 9x plus 2. 9x plus 2 there, okay? All right, so we will divide this, and so this is it. Let's solve for x, and then the angle RST, okay? All right, and so multiply both sides by 2. The left side will become 17x plus 13, and this is equal to 2 times the quantity 9x plus 2. And so we will continue with 17x plus 13. This is equal to 18x plus 4. And then subtracting 17x, our next line will be left side 13. is equal to x plus 4. There, okay? It's equal to x plus 4. All right, so subtracting 4 from both sides, subtracting the 4 and subtracting the 4, x is equal to 9, okay? X is equal to 9. All right, so that's it. We can now solve for the angle. All right, let's solve for the angle RST. Angle RST is equal to 9x plus 2. All right, so solving for the angle. Solve angle RST, which is equal to 9x plus 2. And this equates to 9x means 9 times 9 plus 2. Okay, and this will be 81 plus 2, which is 83. Okay, this is equal to 83 degrees. There, this is our answer. Check and verify. Let's verify the answer. 83 degrees is the answer there. All right, and so let's continue with our next, number 30. Number 30 now. All right, here's our next. Okay, the measure of arc PSR is 21x minus 1. So where is PSR? This is our PSR. PSR, that's the arc. And this is supposed to be 21x minus 1. There, okay? All right, so our working equation will be 21x minus 1 divide this by 2 is equal to the angle 10x plus 5. There. And so this is divide, of course. This will be a divide there. All right, so simplifying the equation, multiplying both sides of the equation by 2, the equation is reduced to 21x minus 1. This will be 20x plus 10. There. Okay. All right, so subtracting now 20x from both sides. There. Our next line will just be x minus 1 there. And the right side is just 10. And x is 11, okay, after adding 1 to both sides. Our x is equal to 11. Yes, okay. All right, so we're asked to get the measure of the arc PSR, okay? And that's 21x minus 1. So solve for arc. Solve for arc PSR, right, which is equal to 21x minus 1, okay? And this is equal to 21 times x, so that's 21 times 11 minus 1. So that's 21 and 21, that's 231, okay? Yes, 231 minus 1, okay? So this is equal to 231 minus 1, which is 230. This is equal to 230 degrees. Spelling. There. All right. So that's 230 degrees. All right. So let's check and verify. There. It's 230. So this is correct. Let's proceed to number 31. Clear the screen. Continue with the next number 31. All right. Here's the next number. All right. Let me see the next figure. All right, this time we have two seconds, okay? 2 seconds. So we have a theorem here. A theorem, all right. So we have here something like if 2 seconds intersect at the exterior, intersects, if 2 seconds intersects at the exterior of a circle, okay, if 2 seconds intersects at the exterior of a circle, then the angle formed is equal, okay, equal to 1/2, okay, equal to 1/2 of the difference, 1/2 the difference of the intercepted arcs there. Okay, if 2 seconds intersects at the exterior of a circle, then the angle formed is equal to 1/2 the difference of the intercepted arcs. Okay, difference. Okay, all right. So let's check our spelling. If 2 seconds intersects at the exterior of a circle, then the angle formed is equal to 1/2 the difference of the intercepted arcs. So from our figure, it's the arc TJ minus arc MK, okay, divided by 2. Okay, so it's like this. Let's put this first at the clipboard. All right, so all right, so this will be our theorem, and we have the arc TJ. All right, arc TJ minus the arc MK. All right, divide this by 2 is equal to the angle in the question mark. So that's angle, let's just call it TLJ, okay? Angle TLJ there, okay? This is our working equation for this diagram, okay? There. So the arc TJ, that's the bigger arc, minus the smaller arc MK divided by 2 is equal to the angle TLJ. Okay, all right, let's use the numbers now. TJ is 149. Okay, so we have here 149 minus the 43. Okay, divide this by 2. This equates to, all right, that's for the angle TLJ. Okay, angle TLJ. All right, so we'll just mark this X, okay, for our simpler solution, okay. Let this be equal to X, okay. There, okay, all right. So this will continue with 149 minus 43. So this is 106 divided by 2, and this is equal to X. This is equal to X, okay. 9 minus 3 is 6, 14 minus 4 is 10, so we have 106 divided by 2. This gives us 53. Our X is 53. And this will be in degrees. Yeah, okay. This would be our angle. All right. Let's check and verify the answer. So this will be 9 minus 3, 6, 14 minus 4, 10. We have 106 divided by 2. We have 53 degrees. Let's check and verify the answer. All right, so this is 53 over there. Let's continue with the next number. Let's proceed to number 32. All right, number 32. All right. Okay, here's number 32. Let's mark our angle with a question mark. Let's just label it with X. Okay, all right, for a simpler solution. All right, so we have 2 intersecting arcs here. 2 intersecting arcs. So we have X, the angle, is equal to 156 minus the 46, divide this by 2, okay? Divide this by 2, and this will be our angle, okay? So X is equal to, all right, how much is this? This is 0 and 1 and 110, all right? This is 110. We divide this by 2. Okay. Yes. All right. So our answer is 55. There. Okay. All right. So 55 degrees is our required angle. Let's check and verify. There. Okay. And the answer is displayed right there, which matches our solution. 33 now. Let's continue with 33. There. All right. So we still have the intersecting secants. So we will still have this theorem there. All right. And so our working equation here will be arc QN. Okay. Arc QN. All right. So that will be 165. That's the arc QN. All right. Minus the smaller arc 30x plus 3. There. Okay. Now, if you divide this by 2, if you divide this by 2, this will be equal to 51. Okay. So this is equal to the angle at the exterior. Okay. There. This is our working equation. All right. So solve for x first. Okay. That's the requirement. All right. So multiply both sides by 2. This will be 165. This will be minus 30x. That'll be minus 3. This is equal to 102. There. Multiplying both sides by the equation and at the same time removing the parentheses. This will be the next simplified version. All right, so this will become 165. Combining like terms, this will become 162 minus 30x. This is equal to 102. Okay, let's do a transposition. We will have 162 minus 102 is equal to 30x. There, interchanging the 30x and the 102, and at the same time changing the signs. All right, so what do we get in the difference? This will now be just 60, okay? Yes, 60 is equal to 30x. And then dividing both sides by 30, okay, we will have the next line. Let's do it at the right side. Okay, let's continue here. Let's continue over there. So we can now write 30x equals 60. So this will be 30x is equal to 60. There. And then we divide this by 30 and divide this by 30, and x is equal to 2. Okay, so x is equal to 2. And that's our final answer. X is equal to 2. There. All right, that's it. Let's check the answer from the computer. Yes, it's a 2 there. All right, so this must be correct. Number 34. Let's clear the screen and continue with the next number 34. All right, here's the next. And we still have the same intersecting secants. This theorem still applied. All right, let's see our equation. All right, we have the angle 34x plus 1. That's 34x plus 1. That's the angle. That's equal to 1/2 the difference of the arcs. So our bigger arc is 128. Our smaller arc is 58. All right, we will get the difference and then we will divide this by 2. By 2, yes, there. All right, so this will be our working equation. All right, let's simplify. All right, what do we get here? We have 128 minus 58. That looks like 70. Yes, 70. All right, so our right side is 70 divided by 2. So this continues with 34x plus 1, which is equal to 70 divided by 2, which results to 34x plus 1 and right side is 35. There. Okay, and what do we have here? Subtracting 1 from both sides, this will be -1 and -1. We get like 34x is equal to 34. And x is equal to 1, okay? Dividing both sides by the 34, we will have x equal to 1, okay? That's our answer. All right, x is equal to a value 1. All right, very simple answer. All right, check and verify. Yes, it's a 1 over here. All right, so this must be correct. All right, 35 now. Let's continue with the next number, 35. 35. Oops, the answer is displayed. Let us just do the solution. All right, okay. All right, so that's 18x minus 8 for the bigger arc, and the smaller arc is 52. Okay, let's determine the angle SUC. Okay, all right. I was able to glance at the answer, but I was not able to memorize it. All right, but we shall check and verify the answer later. All right, find the measure of SUC. SUC. We're looking for the angle SUC. So we're looking for this angle. Okay, this angle there. Okay, SUC. All right, let's have our working equation. The angle is 4x plus 15. So we still have two intersecting secants. That means this particular theorem is still applied. And our working equation is 4x plus 15. That's the angle, is equal to 1/2 of the difference. Okay, so we will get the first arc 18x minus 8, the larger arc, minus the smaller arc 52. Okay, and then the difference is divided by 2. So this will be divided by 2 here. There. Okay, so let's simplify the equation first. All right, what do we have here? The left side remains 4x plus 15. So this will be 4x plus 15 is equal to 18x minus 8. So that'll be 18x minus 60 there. And we have to divide the right side by 2. Okay, yes. The right side by 2. All right, so the right side will be reduced to smaller numbers. The left side remains 4x plus 15. The left side remains 4x plus 15. This will become now 9x minus 30 there. And then we subtract the 4x. And we subtract the 4x. Next line is 15 for the left side. The right side is 5x minus 30. All right, we proceed by addition of 30. Add 30 and add 30. The next line becomes left side is 45, right side is 5x. Okay, and x looks like 9. Okay, we shall continue over the right side over here. Okay, and our working equation is 5x equals 45. We continue by division by 5. Continue by division by 5. And x looks like 9. Okay, x looks like 9. All right, so x is equal to 9 after division. So x is equal to this answer. All right, we're asked to get the angle SUC, which is 4x plus 15. Okay, so angle spelling. Angle SUC is equal to 4x plus 15. Okay, we substitute now our 9. Okay, so this is equal to 4 times 9 plus 15, and this is 36. So this is equal to 36 plus 15. How much is this? That looks like 51, yes? This is equal to 51. There, 51 degrees. Is this the answer? Check. Yes, it's the answer. There, okay? So this must be the right answer. All right, so we're going to the last question. All right, let's clear this number, proceed to the next. All right, let's continue with the next. All right, the last number, 36. All right, we still have two intersecting secants. This will still be the applied theorem. All right, our requirement is the angle DBF. All right, DBF. Okay, so our working equation is the angle DBF 46x minus 1. This is equal to 1/2 of the difference of 167x minus 1. This is the bigger arc minus the smaller arc 76x. Now you will have to divide this by 2. There. Okay, you have to divide this by 2. All right, so what do we have here? Okay, so let us simplify first. The left side will remain 46x minus 1. Okay, this will remain 46x minus 1. And what do we have here? 167x minus 1. Removing the parentheses, we have minus 76x. This will still be divided by 2. Okay, there. All right, and so this will still be division. All right, so combining like terms. All right, combining like terms. 167 minus 76. What do we have there? 167 minus 76. This is 1 and this is 91x. Okay, so we have 91x at the right side. So this is 46x minus 1. And this is equivalent to 91x. All right, 91x. And we still have that minus 1 there, okay? All right, we still have the minus 1. And we still have the divided by 2, okay? We still have the divided by 2 there. All right, so this is division. Okay, and so we will multiply by 2 both sides, okay, both sides of the equation. So times 2, this will be 2 times 46. So this will be 2 times 46x minus 1, and this will be equal to 91x minus 1. Okay, there. All right, so this we have 92x. Continue with 92x minus 2 is equal to 91x minus 1 there. This will become 2, of course. This is times 2. This will become 2 there. All right, so we have x is equal to 1. This is x is equal to 1 there. Okay. All right, multiplying by 2 there, that's 92x minus 2 is equal to 91x minus 1. All right, so subtracting 91x from both sides, that is x equal to 1. All right, so we're asked to get dBf. So can we solve that orally? The measure of dBf is 46 minus 1. That looks like 45 degrees, okay? So our angle is 45 degrees. 46x minus 1. So the angle is 46x minus 1, and that is equal to 46 times 1. This is 1, and this is minus 1. That's 45, okay? 45 degrees. There. All right, that's our answer. Our final answer is 45 degrees. All right. Let's check and verify the answer. Yes, it's 45 degrees. All right, so that'll be all, and see you later.